Hello, everyone. We'll be starting in 1 minute. Hello, everyone. Welcome to the live demo for the new Verasys control system presented by Johnson Controls. I'm Manavan Kitsky, Product Marketing Manager for Johnson Controls. Today's presentation and live demo will give you an opportunity to see how Verasys can help increase productivity in light commercial buildings. You will learn about the benefits of remote connectivity to not only help you proactively care for your HVACR system, but also how to address potential equipment problems before they become emergencies. Before we begin, please note you'll be able to ask questions to our expert. At any time during the presentation, you can submit your questions via the chat, or you can use the Q&A feature on your console. Finally, a recording of today's presentation will be made available to you after the event. Now, let me introduce today's presenter. We have Ham Donishman, who is the Senior Product Manager for Johnson Controls Building Technologies and Solutions. Ham serves as a Product Manager for Verasys and Smart Equipment at Johnson Controls. During his 25-year career with the company, he's held a variety of roles, including Operations Manager of Installation and Services at Camp Pendleton Marine Base, Program Manager of System Integration Services, and Engineering Manager of System Integration Products. Ham holds a Bachelor of Science degree in Electrical Engineering and a Master's of Electrical Engineering from the University of Louisville. Ladies and gentlemen, here is Ham.
Thank you. Thanks, Manavan. I appreciate the intro. Again, thanks for everyone to joining us on this call today. My name is, again, Ham Donishman, and we're going to be talking about our new product called Verasys, which Verasys is the product that we have developed within the last year, and we have made an introduction the last ASHRAE in January of 2017. So my first slide is really talking about a perfect elevator speech around Verasys. What we really have defined here is Verasys to be a simple user experience, and making sure, and this is very important for everyone to understand, is that it's not about programmable controls, it's about configurable controls. And one of the key attributes that we take away from this, and at least a requirement, was we did not want to have any tools to be used within the system. So what that really means is that from a controls perspective or equipment perspective, we did not want a contractor or a controls contractor, mechanical contractor, to be on site and be able to take out a laptop and do programming of a controller from a sequence of operation. The Verasys itself, the controllers are pre-configured from the factory. They can be installed in the field, or they could be mounted on your equipment. That's why it's more of the experience of equipment and controls. And then again, the big thing about what we really focused on is about plug and play. So this is an elevator speech around what Verasys means. The key takeaways are configurable controllers and then plug and play. And where we're fitting this product is around light commercial business and light commercial space within North America. As far as the mid-market and light commercial, some of the high-level features that we're going to discuss today, and I want to touch on those on this slide, is that, again, we have pre-configured type of parameters. They're already being set at the factory. Its configuration are very simple, and you could do that through your phones and your app from a mobile device that you have, and that's how we interact with the system. Again, no field programming is needed. We're talking about no software tools, and that's in this type of space. And then as far as trying to lower the installation costs from a labor perspective, This is a key attribute for us as well. So when we talk about plug and play, the term plug and play is a little bit of a loose term, and you probably hear that in many different industries. But plug and play for Verasys, it truly means plug and play. And what I mean by that is that when you have your equipment layer with your controllers that are controlling your primary type of systems, rooftops, and things like boilers and chillers and things like that, when you connect them together, there is no programming. You configure them, and then when you connect them with a certain amount of rules from addressing and communication wiring, everything comes up and communicates and starts controlling. And the other side of the plug and play, it's not just about your primary controllers. You also have your secondary controllers like your zoning system. All of that is also plug and play. And then the third level, which is really your device layer from a sensor and actuator perspective, and that also is plug and play. So what that means is if I have a sensor hooked up to a controller, and if it's a humidity sensor, for example, it automatically recognizes that is a humidity sensor, and it connects to the controller, and it starts the sequences of what it needs to do with that humidity sensor. So again, plug and play from all different layers. The other attribute which is very important for Verasys, and we focus around our rooftops, around technology, around smart equipment, and fault detection diagnostics. And fault detection diagnostics is not a new term. It's been around for a very long time from a technology perspective, but from an HVAC perspective, it's been fairly new, and it's picking up momentum around ASHRAE and what FDD is about. So what we have done here with FDD, we have provided the embedded FDD solution within our equipment. And what that means to the end user or our customers is that one example of that is our refrigeration within the equipment itself, our rooftops. We are monitoring our refrigeration cycles, and we are providing algorithms that are embedded within our controllers that we'll be able to decide when we have an actual fault before there's a major failure. So think about the value proposition around that, because when it comes to servicing a rooftop, and beforehand, if you know exactly if you have some sort of a refrigeration leak, or you have too high of a refrigerant, or if you have some sort of a heat transfer issue, and you can remotely connect to the system and be able to integrate the system and be able to understand what your superheat is or your subcooling is, that's the kind of information that makes the system very powerful. And last, which is probably one of the key items that I make sure that our customers and contractors fully take advantage of, is remote connectivity. Remote connectivity to the system, which is a very simple connection to the what we call a smart building hub. And having that remote connectivity is very important because it allows you to be able to understand the system. I kind of call it in a sense that your system becomes alive. If you don't have connectivity, there's a lot of functionality that you lose on. You know, even this fault detection diagnostic that I was talking about, not having that remote connectivity does not allow you to be proactive with that customer. And then be able to reach that system from anywhere or any part of the world that you're in, that you could connect to the system and then be able to react and be able to do something about that system itself, and be able to override certain things, or be able to even fix the problem remotely. So remote connectivity is a very key attribute of this system. The next two slides, we have taken some information from Energy Information Administration, and the data here that I'm showing just to give you some idea around light commercial and the building stocks that we have in this space. Now, this data is only going up to 2012, but we have seen indicators up to 2016 that the data is definitely tracking and it's increasing. So as you could see here, that there are many different building stocks, and the building types are definitely growing in this space. And when I go to the next slide, you understand what I'm talking about, in a sense that there are so many of these buildings that really don't have any kind of BMS system or BAS system. And by not having a BAS system doesn't mean they cannot take advantage of the features that we could provide, and then be able to save them the energy that's needed, and then be able to even have a system, a simple system like Verasys installed, and have a very quick turnaround payback on what they could provide to the end customer from an energy savings, from a efficiency of the system itself, and then how you maintain that building as it goes through the life cycle of the equipment and controls. So these two slides really shows where we are from this space perspective and the percentage of where we are from a square footage all the way to a certain square footage that this Verasys system really plays well. Because if you go over that boundary, I'm sure a lot of you on the phone will agree with this, is that if you go over a certain boundary of configurable controls and then larger the square footage of the building gets, then you become more of a complex system. And then when you become that complex system, then you really get out of that Verasys configurable type of a control system. This needs to be very simple. This needs to be easy installed, and then be able to get your system from a controls and equipment perspective as simple as possible for your end users to be able to see the system and be able to control the system. So if I look at the light commercial opportunity, some of the examples that I have on the screen here are really the examples we've been looking at for past several months, couple of years. And the areas that Verasys will play really well in is around retail, dock in a box, what we call dock in a box, and these could be clinics, part of the larger healthcare system. Obviously K-12, depending on the type of K-12 it is. Again, you're talking about light commercial building. And then we're looking at some big box stores, more from a national account perspective, and even restaurants for that matter, and then warehouses would kind of complete that whole building stocks of what we're going after. Again, when I show this slide, I typically talk about 5,000 to about 100,000 square foot. And that's really the area that we want to play in from a Verasys perspective, and then all the application that can support from the building stock itself, and then also from the Verasys system itself. So let's talk a little bit about applications. From an application perspective, we focused very heavily at the first go around from a Verasys and our equipment that we manufacture out of our Norman, Oklahoma. So when you look at our rooftop, a lot of what we sell and a lot of what's out in the market today is single zone rooftops. So that is very much a simple system. Today is a lot of thermostats out there that are being controlled by this. And so having that application, obviously, it was very important. You're covering a lot of the percentage of the market by having that constant volume, simple single zone system. So that is one application we support under Verasys. The other applications that we are also providing is we're taking advantage of now, we're taking it to that next level of the zoning system. So even from a 5,000 to 100,000 square foot buildings, you will have certain situations that you will have some level of zoning. They could be changeover bypass system, your typical zone damper with bypass damper. And then you could also have a VAV system, which we have VAV boxes with that being used for a zoning system. And at the same time, we could change the equipment itself based on being a heat pump or a constant volume or a splits. So all of those applications are supported under Verasys with the components that are available today, and everything is a plug-and-play system for all of those applications. Configurable controls and plug-and-play system. As we move forward to other types of applications, we are looking at terminal units. We're looking at chillers and boilers. But when I say chillers and boilers, it's really, again, from a light commercial perspective. This product is it's a global product for us. And when you look at the European market, there is a lot of mid-market light commercial type projects in Europe, and rooftop or DX cooling is really not very popular there. But what they do very popular there is small mini chillers, small boilers, and they do a lot of fan coils and terminal units, chill beams. So we have applications also at the same type of architecture that comes underneath Verasys that's going to give us that plug and play and configurable controls for those types of applications as well. Also, we are going to be looking at lighting, and we are doing lighting today with the current release, and we can basically bring in some simple lighting into the system, and then we can bring in some refrigeration monitoring, and we could bring in energy meters at the level that we need to be able to do certain level of load shedding. So there's a lot of different applications that could come in to the Verasys system. So when we look at the whole differentiation in the market on the light space, when we say Verasys can integrate, is that it's really about what we can do in the building. It's not just about HVAC, but it could also be lighting. We could tie in refrigeration. We could tie in any kind of ancillary type of inputs. When we could do energy metering and lighting, and all of that can be integrated into one system. Let's talk a little bit about the architecture. I'm going to show two different levels of this. So the first level is really, again, back to that single zone rooftop, very simple. A lot of the rooftops are out there, a lot of the buildings out there are in this type of space. So when you look at what we can do with our architecture, I could take what we call a smart building hub. Smart building hub is our main point of interconnection into the building, and the smart building hub can connect up to 100 devices. And those 100 devices can be a combination of smart equipment rooftops, or it could be a third-party type rooftops like Trane, Lennox, or anybody else's. And we could bring that into our system by using different controllers. In this case would be what we call a TEC 3000. All of this that you see on the screen right now is plug and play. It uses our equipment, what we call equipment model, and that is really the secret ingredient of bringing plug and play into the system. So from an equipment perspective, even though if this is a third-party rooftop, it really doesn't make a difference to us because our controller is what's doing the job of doing the plug and play into the system. On the other hand, if it's a smart equipment, we have an embedded technology of a smart equipment platform inside of our rooftop, which not only connects to the Verasys system with a plug and play solution, but also has a lot more advantages around fault detection diagnostics, as we talked about earlier, and a lot more information around what's your system doing within the rooftop itself. The TEC 3000 on the third-party system, basically it is a controller, it is a backnet controller, but it's a simple interface from a thermostat control into a third-party controller, a third-party piece of equipment. And the last thing you see all the way to the right is what we call our IOM module for Verasys. And this is where I bring in other types of systems into the Verasys itself. So this could be lighting, this could be a simple fire alarm input, this could be a meter, and that's how we bring other types of ancillaries into a Verasys system. So to make it just a little bit more interesting is that now we're talking about zoning. So basically the same architecture with one smart building hub that could go up to 100 devices. So yes, 100 rooftops. Out of those 100 rooftops, 10 of those can be zoning. And for each zoning, even it could be a mixture of changeover bypass or a VAV. For each system of the zoning, we could handle about 32 VAV boxes or 32 changeover bypass zone damper. On our changeover bypass zone damper, we could actually mix and match a zone damper or a VAV box. So it really doesn't matter if it's under a changeover bypass. It could be either or. On their VAV system, it has to be a VAV box or a VAV controller. So again, the architecture is a little bit more complex, but again, everything you see on this screen, especially on the bottom of the screen, all of that is plug and play as it comes into Smart Building Hub. So number one thing what I tell contractors is that if you could follow the communication path, understanding your riser diagram, if you could follow the addressing that's needed based on our documentation, that is the most difficult part about installing a Verasys project. After that's completed, when you power everything up, everything will come into the system and starts operating. And at that point, you will make simple configuration changes like adding descriptions, changing set points, adding schedules, and in a case of VAV, you would have to put in your balancing information, which is no different than any other system in the world. Let's look at the components. Everything you see on the screen, that is the entire set of components for Verasys. We did a lot of hard work to make sure we keep our SKU numbers down, because having more SKU numbers, it just creates more complexity. And the challenge of the SKU numbers really came down to VAV controllers. So I'm going to spend a little bit of time on that. And the reason I say that, because there's so many different configuration of VAV. You know, you could have series type of a fan, you could have parallel, you could have dual duct, you could have all kinds of different VAV applications. What we've done here, we have 3 models of our VAV controllers, and that is it. And it's based on heat. So if you want a VAV controller that does electric heat, you would order that one model. If you want hot water, you would order the second model. If you want SCR, proportional, you would order the third model. All the other configuration based on, do I have a fan? Do I have one stage as electric? Do I have supplemental heat? Is it hot water? Is it series fan? Is it parallel? All of that configuration can be done through the Verasys system, and it's a simple drop-down menus, which I'll show you during the demo. So again, keeping the SKU number down was very important to us. You have the smart equipment platform, which is all the way up to the top left-hand corner. That is our smart equipment platform, which has an embedded system within the controls at the factory. And then I've talked a little bit about our terminal equipment controller, the TEC. We use that for our third-party single-zone rooftop units. We also provide what's called a Verasys equipment controller. And that Verasys equipment controller, it's actually very important to us, because now we're not just talking about equipment, but we're also talking about controls. So if there are opportunities for us that we could go inside a project or a building that have an existing changeover bypass system by a third party, then we will be able to use this controller, install it on a third party unit, and then utilize our own controllers to do the zoning. So again, we're not holding back on any type of a zoning system, even if it's provided by somebody else. We could add our simple controls, do our plug and play and configuration, and then tie that right back into the Smart Building Hub. For every zoning system, we have what's called a zone coordinator. And this is important because the zone coordinator, again, there's no programming here. You configure it. And it's important both from a changeover bypass perspective and VAV. So for every VAV system or a changeover bypass system, you have to have a zone coordinator. A zone coordinator does the sequence of operation that's needed for a changeover bypass system, and the way we do the sequence of looking at all the zones and doing the voting that's needed to be able to recognize who needs heat, who needs cooling. And then really the same thing with the VAV side, and then be able to understand what's going on in the space and how we could adjust the rooftop of what type of a cooling it needs to the zone itself. And then obviously the VAV boxes themselves can bring on the heat as needed, if there is heat. I've already talked about the VAV, which is our ZEC, what we call a ZEC 410, 3 models of that. The zone coordinate controller is a 310, ZEC 310. So for a zone damper, we have a controller here that has actuators already built into it, and the VAV has actuator built into it, plus the transducer, and then we have our bypass controller. All of those look very much the same because they are the same. They're the same controller. It just has different application running on it. And then last is our Verasys IOM module, which is part of the system. And one interesting about Verasys IOM modules is, again, I talked about lighting, I talked about simple fire alarm coming in. One of the feature sets which I will demo is called interlocks within the system. Even though we say where everything is configurable, even interlock is configurable. And what that means is, I give you an example of a simple photocell light coming into an IOM module, and then based on that photocell, I will be able to make a determination within the system. If that photocell is greater than this or less than this, I'll take an action. And that action is to turn on an output. And that output could be wired into a light. So those are the simple, what we call interlock, that we could take an input and then connect it to an output to do a certain action. All right, I'm coming to probably hopefully the best part of this presentation today. I'm going to be demoing live, and I am going to tie into remotely. I am right now in Louisville, Kentucky, in our Johnson Controls office. There's 3 sites that are on the, you see that on the picture right now. And the site on the left-hand side, on the upper left, is what we call Olmsted. It's a historical building where they do weddings and parties and things like that. We installed 3 York split systems in this space, and it had existing 7 train single zone rooftops as well. And we went in with our Verasys system and tied all of those in back to one Verasys project. On the upper right, which the one I'm going to go into, is another business here in Louisville, Kentucky. It's a catering business. This one had an existing train changeover bypass system, and it also had additional 4 train single zone rooftops. And it also, what we did on this particular job, we monitored some of their walk-in freezers based on the information that they needed. It's very important. This is a catering business, and they must have that information very closely handy. So what I'm going to do, I'm going to click on this hyperlink that I have on this, and it should open up my browser here. Sometimes this takes a little bit for some reason, pulling up my browser. So just give it a few seconds here. Always fun to do things live, so it's coming. All right. So what you're seeing right now, I'm not going to spend a whole lot of time on this, and maybe we'll have a different session about this, but within the last 2 months, we've been experimenting with Google Maps. Google Maps is a free, obviously, hopefully everyone on the phone knows Google Maps. It's a free software. You need to have a Google account to get into it. And we noticed this feature that we could use from a standpoint of creating special maps, custom maps that are associated to your account. So what I've done here is a very simple map. I've taken all my sites, all my Verasys sites, and I've put a bubble throughout the country. And within that bubble, I could click on it and be able to provide all kinds of information. And a nice thing about this is, and I'm not going to spend a whole lot of time on this, but if you look at it from a contractor perspective, if I have multiple jobs within a city, and if I want to have access to all of them on my phone or whatever I got to do, I could do this type of tool in front of me and then be able to interconnect with all of them at the same time, so I don't have to search for things. The other thing is nice about it, for example, if I click on this Masterson's Food, it pulls up the information. That's the location of it. I have a link to where Verasys hub is, which that's what I'm going to be clicking on. I could add other fields as far as installation date. I could have my project files stored on a Google Drive. I could have my information regarding who installed it. As you can see, it's a very nice feature to have, especially when it comes to technical documentation. So for example, even a project description. So if I click on this right here, that will pull up my documentation on Verasys Smart Building Hub, and I have multiple different documentation here. So everything could be at palm of your hand. So I'm going to go ahead and go into the Verasys link, and the first thing it should do will pull up a login screen. So we have to create credentials, and this is one of our security login that we have to have. Messed up my password. So I'm logging into the system. And so I'm logging into a system which is the Masterson catering system. And you'll get a view like this. So what this is showing me right now is that I have multiple single zone rooftops. I have named them obviously differently, kind of given a description of where it is. I've also have my IOM module here, which I'm monitoring my temperature on the freezers. And then on the bottom here, this is where I have my changeover bypass system. And the changeover bypass system here, this is my zone coordinator. I'll have my rooftop, and then I will have all my zones that are associated with that equipment. So there's a relationship right now between the rooftop and all the zones going back to the zone coordinator. And that's why you see a little bit of indentation here to kind of give you that indication that this is a zoning system. On the left-hand side, you'll see tree structure, which is built into the Smart Building Hub. But this is the key around plug and play that I was getting ready to describe to you. So I'm going to go ahead and click on one of the rooftops. What this will show me is what we call a home screen. Now this home screen, right now this particular unit is running idle in a fan-only mode. So it's not cooling, it's not heating. If there was any kind of critical alarm, you would see it in this case right here. There is no critical alarm. I have my supply temperature, I have my space temperature, and the fan is cycling, and it's continuously running. And that's how we set up this particular rooftop. What you see on the left-hand side, and you saw it hopefully pretty quickly here, this tree structure was created by the controller that's in the field that is controlling this rooftop. So if you recall the architecture that I drew out, and I had a Smart Building Hub and then a straight line going to a TEC to a third-party rooftop, that's what's happening right now. I am remotely connecting to a Smart Building Hub, and the Smart Building Hub is serving these pages up to me on my computer, which everybody else sees, but the information that it's being structured here coming out of the controller itself. So that's where the magic happens. The magic happens at the controller and then serves up the information. So as you can see, I could go in here fairly quickly and be able to look at other parts of the system. And it's a very fast system from how it's pulling in information, and it provides you what things you need to do. So for example, if I really want to shut down that unit right now, I could go in here and say shut down, and I'll save it. And I'm physically actually shutting that unit down right now to tell it, you need to stop running. So what that should do, hopefully eventually, I'm not sure why, I'm having a little bit of communication issue here. I'm going to try this one more time. Let's say, okay, it's already been on a hold. Okay, it did shut down. So I should have control off. So the system did shut down. Now this is a catering business. I better go ahead and turn it back on. And I'm going to go ahead and try to remotely turn that unit back on for them. I'm having a little bit of communication issue here. I'm not sure why, but I'll go ahead and save it. And that command will go down, enabled. So then as soon as that's enabled, it'll turn it back on. So things like set points, these are the configuration parameters. I was saying that earlier. I could come in here and make the changes that are necessary. These would be my occupied cooling, occupied heating, unoccupied cooling, and then unoccupied heating. I have a built-in schedule that I could go in and set the schedules for every unit. So one of the things that is a very nice feature as well is that every controller holds its own schedule. So if you ever lose connection to the Smart Building Hub, it really doesn't matter. The Smart Building Hub is nothing more than an eye into the system. So I am allowed to go through the SBH right now, Smart Building Hub, and I'm able to do what you're seeing on the screen right now. But again, all the smarts are pushed down to the controller level. So these schedules that I'm showing to you right now, and you could go in and add new things if you need to, are being saved down to the controller level. With the TEC, there's other settings you could do. I could actually go in here and change the actual language. We support up to 3 different languages on that TEC. So if I change this to French and download it, the screen in front of the TEC, which is a touchscreen device, will switch to a French language. Not that I want to do that now, but that's the type of things you could do remotely. And the reason I could do it, because I have an administrator password. So there is credentials here. I could allow you to be just a tech user, or I could allow you to be just a user itself, end user itself, and the credential changes. So you're really not allowed to do all these changes that I'm showing you right now. I'm just giving you some of the features that we can do with this system. And then you got your network setup. And one of the network setups you could do here, you could actually physically change the address, which I'm going to try to show you guys that in a minute. One of the other nice feature here, and again, I'm going through the Smart Building Hub, is that I have what's called trend. And what trend is, these trends are all predefined within the system, again, within the controller. It's not in the Smart Building Hub. It's all in the controller. So what just happened, I told it to go give me a trend of the zone temperature of that TEC, that terminal equipment controller, and it drew the trend out for me, and I could zoom into the area that I'm interested in. So that's some of the power behind the trend, some of the power around how this system can react and quickly tell you what's happening with the system. I mean, as you can see right here, it's been trying to drive that supply air temperature, and this is during the unoccupied period of the system. And we have more information around control status. These are built-in sequence of operation and PID loops that are running in the system. So we also make sure we monitor those as well. So if you're interested to see what the PID output of the cooling is, you would have to go into these sections to be able to tell you that. So I'm going to go back to the device list again, and I'm going to show you now the generic I/O. And this generic I/O is really very simple, and all it's going to show us is 2 freezes temperature, and then it's going to show us the steam pressure that we have. Very simple system here. On the zoning system, when you click on the zone coordinator itself, at a high level, it's going to go through and provide you with some what we call a home screen or a home page information. So the zone coordinator is looking at, in this case, is looking at 6 different zones. So at the high level, I have information about the rooftop. What is my supplier temp? It looks like it's cooling right now. And then it goes through and looks at every single zone. What is my temperature at that zone? If it's satisfied, there is no voting going on. That zone it's happy. I have 74 degrees in zone 2. This zone is calling for cooling right now. As you can see, is urgent cooling. Zone 3 is satisfied. Zone 4 is also calling for urgent cooling. Zone 5 is satisfied. Zone 6. So out of 6 zones, again, this is a small building, we have 2 zones that is calling for cooling. So more information, again, around commissioning, and this is on the zone coordinator itself. Now, if I go back underneath the zone coordinator, and again, recall this, that this is a third-party zoning system. This is not a Smart Equipment, York, or Johnson Controls. This is a third-party zoning system. So I'm using one of our, what we call the Verasys equipment controller, and that's what's coming up right now. So it's telling me it isn't cooling, just like it asked for. I have 2 stages of cooling running, and it's trying to drive that supply air temperature down to 55 degrees. That's what it's trying to do right now. Currently, there is no critical alarms within the system. When I do statuses, again, gives you more detailed information of what's going on. I have summary pages of what's going on within the system. And then if I go into commissioning, this is, again, an area that the only place I would need to go to really configure the system and be able to exercise certain part of the system, make sure everything is running okay. Also, even with the rooftop on a third party here, we do have a certain amount of trends pre-configured. So in this area, I'm going to go into, let's say I'll go into status, and then we could actually see how many times this unit been cycling on and off between cooling and fan throughout the time that it's been running for past 24 hours to 48 hours. So these are the type of trends that it's already been pre-programmed. All you do is turn on the controller and it starts trending these values in. So no programming here, really no configuring here. It just automatically starts trending. So again, very important information when you're talking about maintaining a system. Matter of fact, twice today looks like it also went into heating. That's why you got 130 degrees supply air temperature, actually more than twice, 4 times today has actually gone into heating as well. So this is a changeover bypass. As you know, from a changeover bypass system, you will go back and forth between heating and cooling to satisfy the zones that you have within the system. That is the, I guess, the beauty of the changeover bypass system. Probably beauty was not the right term. So that's really this particular system. But as you could see, it's a very small system. This building is about, I would say, around 30,000 square foot, maybe less. They have a big area where they have all the kitchen area where they do all the cooking, and then they have the office area where they have the zoning system. We're getting ready to add an additional 2 more rooftops to this particular job, but that's coming here very soon. The other feature I want to quickly cover here is called interlocks, and I won't be able to do it here, but let me go ahead and cover schedule sync, and this is another nice feature. So from a SPH level, we could create a schedule. It could be multiple different schedules, and I could give it different times, and what it allows me to do, I could go in and select what rooftops or what devices do I want to sync this particular schedule to. So from one location now, instead of going to every single device, which I could do, or every single rooftop or every single TEC, I could go to my single place, which is schedule sync, and then I could blast this particular schedule down to all of them. So let's say if you had 100 rooftops, you could go into one location, set up your schedule, as long as they're all same schedule, and then blast it to all 100 rooftops. And they all get the same schedule. Or you could have multiple different schedule. East wing could be different, west wing could be different. However that works out based on the particular job. We also have other features. This is really where you set up your Ethernet connection into the system. This system also is capable of providing you with email and texting. So when I say email and texting, it's, again, fairly simple. You come in here within the alarm notification, and you have to set up your email address, and you set up a server email address. We have all this written out in the documentation of how to do this. But just to set up the alarm notification, you only got about 1, 2, 3, 4, 5, 6, 7 different parameters to fill out. After that's filled out, you save it. You go into what we call our administration side. And if I go to my own user, this is how I would email and text myself. In North America, all the providers here, AT&T, Sprint, Verizon, you could put in your regular phone number and then put @txt.att.net. I have AT&T. By putting that, if any of the service alarm comes in of this system, I will get a text. I'll also put in my email address, so not only I get an email, I also get a text, So my phone does act very quickly when I get 2 messages instead of 1 messages in this case. So that's really, again, very simple of how to set up your Ethernet connection. And then your Ethernet connection here, this is a setting for that. You could go, I would suggest, most of the time I would do static IP addressing, but you can do DHCP. Again, we have documentation that explains this throughout how to set up all the IP connection. But again, back to what I started this conversation with, it is very important to make sure if you can get connectivity, it really brings the system alive. And as you could see, the demonstration today shows that. All right, that's probably all I'm going to do here, except before I move on, and one last thing, and I'm going to quickly show the power of the plug and play. So I'm physically going to change the address of this to 14. I'm going to go from 13 to 14. And what it should do is that the 13 will go away, 14 will come online. As you can see, it just did. That's our plug and play. The descriptor followed, and then the 13 will go offline. You don't see my phone right now, but my phone just sent me a text telling me I have a new device just came online, 14, and then 13 will go offline within the next minute or 2, or sooner than that. So the power of plug and play is right here. And the reason I say that, if you try to do that with any other BMS system out there, changing an address on the fly, you would have to basically rebind all the information, re-download the controller to be able to get all the information back to where you were before. With this system, I don't have to do any of that because the controller knows that I just changed the address, and all my trends, everything else within the system just follows the system. So there's nothing I'm doing here. All I did is change the address, all the configuration came along. So this is one way to show the power behind plug and play. So some takeaways. I'm going to try to make sure we have enough time for questions. Simple plug and play. I think we said that plenty of times. This is a bundled solution, but it could also be a loose controls as a solution. But to get the best value in the offering, when you combine smart equipment and Verasys together, that is where you get a lot of the value, especially when it comes to fault detection diagnostics. We talked about the loose controls on third-party application. We talked about fully programmable or fully configurable system, no programming, and hopefully I made that clear that there is no programming here. All I've done here is connect to my site through the SBH Smart Building Hub, and the Smart Building Hub through my browser on my phone or any kind of mobile device or a computer, I could do the configuration that I need. Remote connectivity brings your system alive. That is very, very important. I highly suggest if you do have Verasys as a project, make sure you get remote connectivity. Didn't touch on this too much, but this system is fully BACnet compatible. So it is scalable to other BACnet head ends. So if you ever run into a job that you got to tie in this to some other back end, it doesn't have to be Johnson Verasys, you can do that. It is fully scalable. And then with last, we talked about fault detection diagnostic, and that is another key differentiator when it comes to smart equipment and Verasys. So, Manavan, at this point, I think I'm passing this on to you from a summary and benefits, and we'll go from there.
Great, thank you, Ham. Yeah, for the summary, we just want to be sure we're touching on all the benefits with regards to remote connectivity for your light commercial buildings. And as Ham mentioned, that with Verasys, we're providing that turnkey solution to help you save costs, ensuring your comfortable environment and productive workplaces, giving you near real-time equipment data from any device, and finally, just managing those problems for you before they become equipment failures. So very engaging presentation, Ham. We do have a lot of questions coming in from our audience members, and I would remind those that if you'd like to ask a question of Ham, please do so in the questions or chat buttons on your console. Ham, first question from our audience is, how often does the data get refreshed?
So the system is not your typical BMS system, so the only time it gets really refreshed, the controller itself is refreshing data all the time. So when I'm connecting to SBH and when I pull up the system and like you saw the circle, that's the only time that I'm actually asking for the data to come into me. But the controller itself is continuously refreshing when it needs it based on the sequence of operation that are running inside the controller. But from a UI perspective, the only time it comes into me is when I ask for it.
Great. Next question we have is, are there any security concerns with the connectivity platform?
Well, we've done a lot of work around security. Our Smart Building Hub has gone through rigorous type of testing, and we have an external company, actually a consulting company, that comes in and audits our code, our software program around security, provides us with recommendation where we need to, if we have any gaps on security, to fill out those gaps. And then on top of that, we have two things that you have to, it's important, is that you need to follow the documentation that we have around IT connectivity, and that IT connectivity documentation is important to understand and then pass along to your IT department that you're dealing with. And then really the second thing is also we have what we call as certificates. It's very terminology around IT. So, certificates that you will add into the SBH, and that certificate is typically provided by the local IT, and that adds another layer of security. So I feel very confident where we are with SBH today, and we're continuously improving our SBH from a security perspective.
Thank you, Ham. The next question we have is Verasys extendable to other building automation systems?
Yeah, so that was one of the last, maybe I said that too quickly. So the last bullet items I had on the takeaway. So it is scalable. It doesn't have to be, obviously, Johnson Controls Verasys. The Verasys is BACnet certified on all the controller levels, and you can integrate into anybody's BACnet head end. It's a simple integration, no different than any other BACnet system out there.
And the next question is with regarding remote access. Is that for the technician, the company that installed the unit, or the owner of the system?
It really depends on the project. So at this point, the way I could answer that, I think the technician or the owner both could take advantage of the system. And the reason I say that, there's maybe one thing I did not cover. The owner that's inside the building, let's say, if they're inside the building, they also have a Wi-Fi connection, because the Smart Building Hub not only has an Ethernet connection, which you could connect to it remotely through the internet, but if you're on site, it also acts like a Wi-Fi hotspot. So the owner can basically pull out their phone and connect to our hub and then be able to see the system. And that is really our only user experience we have. So again, based on the project, if you do connect it to the internet, I think the technician can see a lot of value, be able to maintain that building and be able to provide the value that's needed for that customer. And then the same thing for the customer. They could see their system. They could get email and texting outside of the technician. And I have several jobs right now that not only I'm connected, but also the end user wants to be connected as well, so they could be able to review their system.
Sounds good. Your next question is, how would you handle any side loop controls that would be required in the building?
Yeah, so the side loop controls, I have to say this has to be a JCI guy that's asking this, so that's okay. But the way we do side loops, you can do some of that through the interlocks, as I explained before. So we have some simple interlocks we could do that could be very similar to a side loop. And the interlocks is not only from one condition, but it also does two conditions based on and or type of logic. But if you truly want to do something, again, if you're doing a side loop that Verasys cannot handle, which means now you are outside of that configurable system, and if you have to do a side loop to maybe maintain some pumps or whatever it is that you're trying to accomplish, I would add another controller to do that. And that controller may not be compatible with Verasys, but at least that controller can do your side loop standalone. So my point is here, if you get into a situation like that, you may be outside of the Verasys configurable system.
Okay, your next question, Ham, is, are the boiler and chiller controls currently available?
Yeah, good question. So the boiler and chiller controllers today are not available yet. It was not part of the first release. Our second release is planned for the September of this year, but it's mainly focused for European market. So at this point, I won't be able to give you the exact answer. Are we bringing those applications and providing them in North America? I think we're definitely looking into that today, not only from a boiler and chiller perspective, but other applications as well. But today they're not available. First release was not available.
Thank you. Ham, we have a question with regards to the previous offering from Johnson Controls, the CCS system. The question is that system still available, or should they now be ordering Verasys?
Well, I would love you to order Verasys all day long. So does that answer your question? No, let me answer it a different way. Yes, I would love for you to switch over Verasys and not do CCS by any means. But the CCS, there's two variations of CCS. One's called a YCCS, which was available to our UPG channel or York channel, and then the other one was CCS, which was provided to our SSNA channel. Today, the YCCS has been discontinued for the York channel. So the York channel, we could only order replacement parts, but from a brand new system, it's been discontinued. For the SSNA channel, the letter just went out just within the last week that certain components have been discontinued, but the CCS offering still has not been discontinued. So if SSNA still wants to move forward in installing CCS, they can do that today.
Ham, your next question with Verasys, can you control and monitor humidity?
Yes, you can. When you say control, let's make sure we're clear. So we have humidity sensors that we could connect to the system, which we could monitor. And from a humidity control, that's really related to the equipment itself. So if you're tied into a smart equipment rooftop, then the answer is yes. We do humidity control as part of the smart equipment platform, which ties in right into Verasys. When we're talking about third-party rooftops, then the answer is no. We're not doing any kind of humidity control on the third-party rooftops.
Okay. Ham, I have another question here. Can you explain why the Smart Building Hub does not detect the outside air temperature?
The Smart Building Hub does not detect the outside. I'm not sure if I fully understand that, but I'll try to answer best I can. The Smart Building Hub, just like the term says, is a hub. It's a portal to your system. If you want an outside air, that outside air could be connected to either your rooftop, or it could be connected to your TEC, which is your terminal equipment controller, or it could be connected to your VEC, which is your Verasys equipment controller for the third party for a zoning system. All those outside airs can be connected and it can be pulled up through SPH. There is no physical wire or physical sensor that can be connected to the SPH. SPH is nothing more than a hub. But the outside air, or any other input for that matter, can be connected to our architecture, which is the different devices, and all of that information can be shared from the SPH itself. Hopefully I answered that correctly.
Thank you, Ham. It looks like we're running out of time here, so we're going to wrap up the questions and answers section at this time. We have all the questions that were asked during this session, so we will be following up with you, setting out an FAQ to get those questions answered. And in conclusion, we do want to say thank you to everyone who was able to attend the demonstration. I want to thank Ham for presenting and sharing his expertise. And on behalf of Johnson Controls, thank you again for attending.
Thank you very much.